Hello everyone, so welcome back. In this lesson, in this video, I'm going to be I'm going to achieve two learning targets. Okay, so what are the learning targets? We call that movement objective. So the learning target, or another word, is objective. So you're going to see in this video two learning targets. And the first one is you're going to be developing formulas for the length of an arc. Okay, and the second learning objective is going to be you're going to be describing Radian measures. Okay, so that will be the goals for this video. So let's start with the first learning target. And the first one is, let me use another pen. The first one is going to be developing formulas for the length of an arc. Okay, so first let's define the arc. What do we define as arc? So an arc of a circle. Okay, circle is a portion of the circumference of the circle. Okay, so let me model it right here. So I'm going to draw a circle. Okay. So this is my circle, and the center is right here. Okay, so I'm going to draw an angle. Okay, the center angle is going to start from, so one way will be right here, and the second way I'm going to make it right here. So remember, this is the center, and from the center to the edge of the circle, this represents the radius. Okay, and the center of the center angle, the angle formed by two radius. Okay, because this one is also radius. Okay, because go from the center to the edge of the circle. So I'm going to refer to the center angle as theta. I'm going to use this symbol to represent the center angle, theta. Okay. So what is the arc of a circle? So the arc of a circle represents this section. So let me just represent this section right here. Okay. It represents a portion of the circumference of the entire circle. It's just a portion. And sometimes you can refer to this arc as a minor arc, and the arc going on the other side. So from here to right here, right there, represents the major arc. Okay. So we refer to this portion of the circumference of the circle as S. So the arc length, you use the letter or the variable S to represent the arc length. So let's write that here. Okay, the letter S is used to represent the arc length. Okay, so again, S represent the arc length, and the arc length represent a portion of the circle. Okay, now let's define what is theta. So theta represents the center angle, the angle formed by two radii. Radian, okay, radian, because that's the singular for radius. This is angle formed by two radii. Okay, so we pronounce that theta, and you write it as theta. Okay, theta is the central angle. And what is the central angle? It's an angle formed by two radii, like this, the plural for radius. Okay, LADII. Okay, of a circle. So its vertex is at the origin. Do the vertex of the angle? Okay, its vertex is at the origin. And now, what does R represent? Again, R represents stand for radius. So R is the radius, okay? And the radius is half the diameter. And remember, the diameter goes from one end, okay, it's go from one end of the circle to the other end of the circle, passing through the center. You must pass through the center. Okay. If it doesn't pass through the center, it's not the diameter. Okay. So to be a diameter is the distance from one end of the circle to the other end, and it must pass through the center. So I define what is the arc length as theta and radius. Now let's develop the formula for the arc length. Okay, so what I want us to do, you're going to consider the following proportion. Okay, and what is the following proportion you're going to consider? Okay, so I'm going to set two fractions separated by the equal sign because they're equivalent. Okay, so I'm going to first consider the angle. Okay, theta. Okay, so on top I'm going to write the part, and at the bottom I'm going to write the whole, part over whole. So theta is a part of the entire circle, the angle of the entire circle, so theta. And what is the angle of the full circle? So a full rotation is actually 360 degrees. So I'm going to write below 360 degrees. Now the second portion I'm going to represent here is going to be, I'm going to consider the circumference. And I'm going to write the circumference in terms of part and a whole. The part of the circumference here, a portion of the circumference, we refer to it as S. Okay. Over the whole, the entire circumference, you can use the entire distance, the distance around the edge of the circle is called the circumference. So it's a total. So I'm just going to write circumference. And okay, what is the formula for the circumference of a circle? Okay, I'm going to put theta here because theta it represents the degree. So the theta is going to be degree. represent the measurement of the angle in degree for now. Okay. So S represents the arc length, and the circumference formula for the circumference is 2 pi the radius, 2 times pi times the radius. Okay. So what I want us to do next, you want to find out S the formula for the arc length. So what I'm going to do, I'm just going to, since I want to solve for S, so I'm going to write this equation the other way around, like that, S over 2 pi r equal. Okay, so I want to solve for S. I want S to be all by itself on the left side, but it's not yet because S is divided by 2 pi r. So to undo, okay, so to undo division by 2 pi r, what do you usually do? Okay, you multiply, you're going to multiply by 2 pi r. And whatever you do on one side, you have to do on the other side to balance the equation. Okay, so actually the circumference of a circle, if you can memorize this, that's great, because from that you can derive, if you set up the proportion correctly, you can derive S. Okay, don't need to, if you set up the proportion correctly, you can then derive S. So now I find out a number divided by itself simplified to 1, and 1 times S is S, equal to, okay, so I'm going to use, so it's simple, okay, I can divide 2 on top and below, so I end up with 2 pi r over 1, oh, sorry, not the 2 anymore, because we simplify top and bottom by the 2, so 180 degrees times theta in degrees as well. Okay. So that's the formula for the circumference. Oh, sorry, for the arc length. Okay. If you're given theta in degrees, so if theta is in degree. So here you see here that yeah, remember, so I can divide the 2 on top and the 2 below. So 2 going to 2 once, and 360 divided by 2 is 180. That's why I end up with 180. Okay, so this is the formula for the arc length in degree. 1 theta is in degree. Okay, so the arc length, 1 theta is in degree is what? It's S equal pi r over 180 degrees times theta in degree. So we derive the formula for the arc length. So now let's move on to reviewing, okay, what you studied so far. Okay, so what is an arc length? How would you define an arc length? Okay, option A. Okay, is it theta, a central angle formed by 2 radii of a circle, where its vertex is at the center? Option B, r is the radius or half the diameter. Option C, an arc of a circle is a portion of the circumference of a circle. The letter S is used to represent the arc length. Okay, so remember, how would you define the arc length? Okay, what is an arc? Okay, so the arc is a portion of the of a circumference of a circle. The letter S is used to represent the arc length. And I model it to you. I drew an example to show you visually what is an arc. And you can form, and so the answer should be option C. Okay. So now can you draw a circle with its radius, the center angle, and the arc S? Yeah, I'm just making sure you just can do something similar to this. That would be great. Okay. So I hope you have an understanding, a better understanding. What is an arc? Okay, the meaning of arc, or the arc of a circle. Okay, and now what formula do you use to find the arc of a circle. Okay, so what I want you to remember is if you can set up the proportion correctly, one for represent the measure of the angles, so from the part over the whole, and also one represent the circumference, the fraction represented the circumference, the part of the circumference and the whole of the circumference. So if you set up the proportion correctly, you can derive the arc length. And you found out to be S equal pi times R over 180 degrees times theta in degrees. Okay. So now let's move on and let's apply what you've learned, what you've just learned. So our first CFU, maybe example for you. Okay, so let's do example 1. That's not the first CFU because I gave you, so I'm going to call it CFU number 3 because I asked you a question earlier. So CFU number 3 is, okay, what is the length of the arc formed by a 90 degrees angle on a circle with a radius of 68 feet. Okay, so I'm just going to rewrite the formula here. S equal, I remember, is pi times R over 180 degrees times theta in degree. Now, from the statement, from the problem, I know that theta in degree is 90 degrees. And the center angle is 90 degrees. And what do we know about the radius as well? The radius is 68 feet. Okay, so what I'm going to do next, I'm just going to replace the radius with its value, which is 68 feet. Okay, and theta in degree is 90 degrees. Everything will be divided by 180 degrees. Okay, so what I notice here, the degree on top and below simplify. So the degree simplify, so I can divide, I can divide by 90 top and below. Okay, so I will end up with pi times 68 feet. So if I divide by 90 on top, I'm left with 1. And 190 goes into 180 twice. So it should be everything divided by 2. And I know that 68 divided by 2 simplified by okay, 34, sorry, 34. So she's going to be 34 pi. Oops, I need to fall. Let me redo that. It's going to be 34. 68 divided by 2 is 44 pi feet. Okay, so because S represents the distance, it represents a small portion of the circumference. Okay, and the circumference is the distance. Okay, so that's why it's one dimension. You only have feet. It's not feet square, feet cube. It's only one dimension. It's the distance. So you should use one dimension. So that's why the unit is just feet. Okay. So again, the arc length is 34 pi feet, or you can use the approximate value. So if your approximate value, you're going to replace pi with its because this one you call the exact value. So if you want to approximate the arc length, you're going to replace pi with its value, approximate value, which is 3.14. So if I do 34 times 3.14, I end up with about, okay, 106.76 feet. So this represents, those two values represent the arc length. The arc length is given with an exact value when pi is left alone. The approximation is when you multiply 34 by 3, the approximate value of pi, which is 3.14. Okay. So that's it. That's the CFU number 3. Now let's do CFU number 4. Okay, for CFU number 4, this time around, I'm asking you to find the central angle. Okay, theta in degree. Of a circle with radius of 35 feet and an arc length of 175 pi feet over 12. Okay, don't be scared. I know it's a function, some of you may be scared, but don't be. So please pause the video and try to, this time around, not to find the arc length, because the arc length has been given to you, but to find the central angle theta. Okay, how would you, okay, how would you do that? Please pause the video and try to do it on your own. Okay. So now let's continue. So we know the formula for the arc length is x equal from the both pi. Okay, so what do I know? I know that that theta in degree is unknown. That's what I need to figure out. I know that the radius is 35 feet. And I also know that the arc length S is 175 pi over 12 feet. So what I'm going to do, I'm going to replace S by its value, which is 175 pi feet over 12 equal pi times the radius here is 35 feet. Okay, over 180 degrees times theta in degrees. Okay, so I see here I have a fraction. So again, you want to solve for the theta. Okay, so what I see here, so what I have to do, what do I need to do here? So what I need to do, I'm going to multiply. Okay, I'm going to multiply both sides because theta needs to be by itself. So I have a fraction of 35 pi over 180 degrees. So I'm going to multiply by the reciprocal. Okay, so that theta can be by itself. So the reciprocal here is going to be 180 degrees over 35 pi. And whatever I do on the left side, you have to do on the other side as well to balance the equation. Okay, and since I'm going to include the feet here, that the feet was on top, so the feet going to be below. So then you see that the feet cancels out. Okay, they simplify and cancels out. So now let's multiply. So the number multiplied by reciprocal always simplify to 1. So 1 times theta in degrees is going to be just theta. Okay, so I'm multiplying this fraction by its reciprocal, so that's why it's just 1, and 1 times theta is theta. Okay, let's continue on the other side here. I have pi on top and below. A number divided by itself simplified into 1 whole, just 1. Then what you're left with, 180 degrees times 175, everything divided by 35 times 12. Okay, so let's multiply. Okay, so you do 180 degrees, 180 times 175. We end up with 31,500 over, I believe it should be in degree, but I'm going to, the answer must be in degree. Okay, so 35 times 12 is going to be 420. So let's divide 31,500 divided by 420, simplify into 75 degrees. Okay. So I'm going to assume this is in degree, and then, okay. So that's the central angle. Theta is equal to 75 degrees. So I think we are done with this example, the CFU number 3 and 4. So next, we are going to move to the second objective was to describe the radian measure. So that's what you're going to do next. Okay, so let me use a new page. Okay, describing radian measure. Okay, so as you progress, in your study of mathematics, and angles, so you will see more references made to the term radians instead of degree. Okay, so as you continue with your math classes to go higher, as you continue to go higher in your math class, you see that people will start to move from degree, use the measurement of angle in degree to radians. Okay, and the reason is because mathematicians believe that radian is a more accurate measurement for an angle compared to degrees. So now let's figure out. So what is radian? So what is a radian? So what is a radian? So that's the goal of the next objective. So you're going to define radian. So definitions. So let's start with the definition for radian. Okay, so the radian measure, so angle can be measured in two ways, right? You can use the degree measurements. Some of you are majority of you now are familiar with the degrees, okay? Or you can use another kind of a type of measurements, which we call radian, okay? So now what is the radian, okay? What is a radian? So that's what I'm going to define here. The radian measure of the central angle theta, okay, is a ratio of the length of the arc so you want to use the length of the arc S2, is a ratio of the length of the arc to the radius of the circle. Okay, so let's say you're given a circle. This is a radius. This is theta, and this represents the arc length S. This is a radius, and this side also represents a radius. Okay, so what is the measurements of theta? So in radian, so the measurement of theta in radian is equal to what? The length of the arc, which we, in trigonometry use S. The letter S represents the length of the arc. 2 is the ratio of the length of the arc to the radius. And what is the radius here? You use the letter R for radius. Okay, so to find theta in radian, you want to use the length of the arc over the radius. Okay, so now theta represents the angle in radian, okay, which equal the length of the arc S over the radius R. So using both this formula, okay, we can derive S, the formula for the arc length. Okay, so to derive the formula of the arc length, you can just cross multiply. Okay, let me cross multiply for you. Sorry. So because you have two fractions separated by the equal sign, you can just cross multiply. So when you cross multiply, or if you want, you can multiply both sides by R, you end up with S, the arc length equal to, okay, R times theta. And we present here theta. Let me say that one more time. Theta is not in degree. If you use this formula, the angle theta here must be in radian, is in radian. Okay, so again, theta here is not in degree, is in radian. That's the radian measurement. Okay. So what is okay, so I wanted to introduce the term 1 radian. So 1 radian, okay, is the central angle that has an arc length of 1 radius. So let me just think a circle right here. This is a radius. So what happened is, if you take the radius, right, take the radius and you wrap it, the length of the radius, and you wrap it around on the edge of the circle, and I see this also is radius. So this size I'm approximated to be R, so I'm not, okay. And you also know that from this side right here to the center, this also represents R. Okay, so now what is 1 radian? 1 radian represents this angle right here, where each side is 1 radius. The arc is 1 radius, and the two sides inside the center as two radii. Okay, so that's what you call 1 radian. Okay, so I describe the radian measurement. Okay, so next I want to describe the relationship between degree and radian. Okay, I think I need to do that. Okay, so let's do that. Okay. Okay, describing relationship between degrees and radian. Okay, so I want to show you the relationship that there is between the measurement of the angle in degree and in radian. That's what I'm doing right now. Okay, so we know that a complete revolution or a full circle, a full rotation of a circle is, we know, is 360 degrees. Okay, so a full rotation in degree. So if you have given a circle, okay, a full rotation or a full revolution is 360 degrees. Okay. Now, we also want to find out what is a full resolution. What is a full resolution in radian? Okay, so that's why we're going to use the definition of radian. So according to the definition of radian measure, okay, we know that theta is equal to, according to the definition of radian measure, theta is equal to the arc length over the radius. Okay. Now, so we want to find a full. So you're doing that for full revolution. Okay. So this S represents the circumference. Now, what is the circumference for a full resolution or a full rotation? One rotation. What is the circumference? What is the formula to find this for the circumference for full rotation or full revolution? Okay. So let me write. So circumference for a complete revolution or rotation, okay, and then over the radius. So we know that theta, what is the circumference for a complete revolution? I know you can tell me it's 2 pi r. So S here, the circumference, the entire, so the arc length will represent the entire circle, the distance around the edge of the entire circle is 2 pi r. And what is the radius? We know the radius here is r. This radius is just r. Okay, so I'm just writing r. And a number divided by itself simplified to 1. So you're left with 2 pi radian. Oops, so should be S here, 2 pi radian. So we know that for full rotation, okay, you have 0 radian, so it's 2 pi radian. A full rotation is 2 pi radian. So, okay, so we can set the relationship, you can conclude the relationship of, okay, that 360 degree, okay, is equal to 2 pi radians. Okay. And 2 pi radians represent, so 2 pi radians represent the exact value. Sorry, the exact, sorry. Okay, the exact value, because you left the answer in terms of pi. So the exact value for full rotation is 2 pi. But the approximate value in radian will be, you take 2 and you multiply by the approximate number for pi, which is 3.14, which is going to be 6.28 radians. Okay, so let's continue. So now I want to find, so we see the relationship between degree and radian. So 360 degrees is equivalent to 2 pi radian. And 2 pi radian is equivalent to 360 degrees. Okay, now if I want to find out half, so if I want to find out what is the equivalent for 180 degrees in radian. So basically I have to divide 2 pi. If I take half of 2 pi, it's going to left with 1 pi. Okay. What about half of 190 degrees is going to be half of 180 degrees is 90 degrees. So what is the equivalent in radian for 90 degrees? So you divide by 2, so you're going to be pi over 2 radians, all right. And what about for 45 degrees? What is the equivalent in radian for 45 degrees? So to go from 90 to 45, I divided by 2. So the next one, I have to take pi over 2 and divide it by 2. I end up with pi over 4 radians. Okay. So if I want to continue further, so what about if I want to find what is 1 degree in radian? How would you find 1 degree in radian? So the way I'm going to do it, I'm going to use this relationship. So 360 degrees equal 2 pi radian. Since I want to find only for 1 degree, I'm going to divide both sides by 260 degrees. Okay, so I'm going to be left with 1 degree over pi over 180 degrees. Okay, you have degree name, right? Okay, and then so pi represents, so that's the approximate value. Okay, that's the exact value. So I know that 1 degree is pi over 180, right? Okay, and if I want to approximate this, I have to replace pi with 3.14. Oops, sorry. Okay, so let's continue. So if I want to find, I find the exact value. Now let's find the approximate value for the in radian. So we know that 360 degrees is 2 pi radian. So I want to find the approximate values in radians. So I'm going to take 2 and multiply with 3.14. So you do 2 and multiply with 3.14, and it's approximately equal to 6.28 radian. Okay. Now, what is 180 degrees? So pi is 3. So the approximate value is going to be 3.14 radian or bar. What about 90 degrees? It's going to be approximately equal to 3.14 divided by 2, simplified to 1.57. Sometimes if you don't write the term wide, if you don't see any symbol of degree on top, like the empty circle on top, it means that the measurement is in radian. Okay, sometimes you don't write radian or bar, you just leave it like this, assume that it's in radian. And for 45 degrees is approximately equal to what? 0.785. Okay, radians. Now, what about if I want to figure out what is 1 radian? What is 1 radian equivalent in degree? What is 1 radian equivalent in degree? So 1 degree between those two. So I know it should be, the degree should be between 90 degrees and 45 degrees, because 1 radian between 1.57 and 0.785. So let's figure out. So I'm going to start with this relationship here. Okay, I know that 360 degrees is equal to 2 pi radian. And I want to find one radian. So I'm going to divide both sides by what? If I want to get 1 radian, you divide by 2 pi. Okay. And you end up with 1 radian. And here you end up with 180 over, okay, I think it's degree. Let me leave the degree, over 2. So we know that 1 radian is 180 degrees over 2. And okay, I forgot the pi. No, sorry, it's supposed to be just pi. Over pi, sorry. You simplify, it should be pi. Oops. Okay, so it should be 180 degrees over pi. And if you want to approximate it, you're going to be divide 180 degrees divided by 3.14. And what number do we get if you do that? I think you get about 57.32 degree for 1 radian. Okay, so the approximate, so this is the exact value. Sorry, so 1 radian in exact value is 180 degrees divided by pi. Now, if you want to approximate this fraction, is going to be, you do 180 degrees divided by 3.14 is 57.32 degrees. Now, if I want to approximate the 1 degree, so I'm going to do 3.14 divided by 180 degrees, but in terms of radian. So the value will be 3.14 divided by 180 is 0.017 radians for 1 degree. Okay, so I'm just showing the approximation. For 1 degree, the exact value is pi over 180 radian. Okay. Next, for 1 radian, its exact value is 180 degrees over pi. And you simplify, if I want to find the approximate number, degree is 57.32 degrees. Okay. Okay, I think this is it. So I'm going to stop here with this on this for this video. For this, okay. So my question is, what is the formula to find the arc length when theta is in radian? What is the formula to find the arc length when theta is in radian, no degree? Okay. So the formula you use to find the arc length when theta is in radian is x equal r times theta. And theta must be in radian, no degree. If theta is in degree, that's when you want to use this formula for the arc length. Okay, and what is the radian? What is a radian? What is a radian? So the radian of the central angle is the ratio of the length of the arc to the radius of the circle. So radian is the ratio of the length of the arc to the radius. And what is a full rotation in degree and in radian? So a full rotation in degree, a full rotation in degree is 260 degrees. And a full rotation in radian, and you find out, is 2 pi. Okay, so thank you for watching my video. Have a wonderful day, a wonderful day, and see you into the next one. Bye-bye.